Hi, so today we will be talking about our LLM Ops Gen AI application, which is a math problem solver. And our main goal was to enhance LLM's capabilities in terms of solving math problems. So in our group, we have myself, Kelly, Alexis, Nick, and Joash. So just to give a brief overview of our demo presentation today, we'll be going over our problem, the approach we took, how we trained our data, as well as fine-tuning our models and training our models, go into our Hugging Face demo, conclusions, and further research. So what is our main problem? Our main problem is that LLMs are bad at solving math problems. LLMs have many limitations when it comes to numerical analysis. So like ChatGPT or GPT-3 is great in excelling in generating and understanding text. But when it comes to dealing with tasks that require more precise logical reasoning, there are many significant limitations. So these models often struggle when it comes to manipulating symbolic numbers and also can misinterpret the specific requirements of math-related queries due to their design on focusing on linguistics rather than numerical understanding. So the main challenge is that LLMs often misinterpret the context or specific requirements of these mathematical questions due to their main design of language processing and not numerical analysis. So our approach is training and benchmarking these LLMs on its capability to respond accurately to math problems. And so we followed a typical LLM ops pipeline where we trained and evaluated data sets. We fine-tuned and trained the model, had model evaluation, and had a UI using Hugging Face for the end user.
The
And
training data that we used was pre-generated using Python. So the idea was that we would basically take some math problems that were pre-solved exactly, and then basically feed it as answer question pairs into the LLM, and then that would essentially train the LLM to basically be better doing math problems.
I'll talk about the fine-tuning of the small LM2 1.7 billion parameter model that has been trained on a variety of education and math-related data. So we initially started with the Llama 1B model, which the small LM2 model is based on. They are both Llama models. However, the small LM2 model is larger because it has been fine-tuned or has been like added on top of Llama. Um, Added like more data related to math and education. And since we wanted to have our own model that was fine-tuned on additions, derivatives, and roots, um, we wanted to start off with this base model and then kind of like compare it to like another model that has already kind of done that. And so we see that our training loss on our own data, it went down pretty quickly and did pretty fairly well on the data set of additions, derivatives, and roots. And a note is that the data for the additions was our primary data set. And in this set of charts, we are comparing like many runs for the training or fine-tuning on the entire data set, including the addition subset for the Llama 1B base model. And you can see that mostly these runs ran for around 2 to 3,000 steps, but there were also times when we run it for less steps. And this was, for example, when we are running it on subsets of the data for like additions or just derivatives and roots. Since the additions is fairly different to the derivatives and roots, additions is mostly numerical with very limited amounts of symbols, and the derivatives and roots, it has more latex type of inputs and outputs. It's kind of very different for the model to understand. So we decided to mostly focus on the additions since we were getting kind of like very mixed results when we use the entire data set. And when we look at the training loss, you don't see the final run that we use, which is called the gentle snowball or the blue line in this chart. It's the most flattest that we have. And you can see that there are also other runs that did perform worse and took longer to converge. And that's where you see two lines that are like one that's very flat and one that's takes very long to lower. And the evaluations on the models, we tried to evaluate using root mean squared error and the percent of the accuracy. However, we ran into difficulties. We had two models, and one of the models is the BFT or the base llama model that we fine-tune, and then the other one is the pre-trained small LM2 model. And the prompt that we used initially for training requested the model to only return the answer to the math problems. So that's why you see very little logical reasoning in text and mostly just the answer. However, the answers are kind of illogical or not returning the result as expected, which is just in number format. And it's returning symbols and it's trying to do multiple steps to get to the answer. And this is for the PTFT or the small LM2 model. Um, this is the same data that we use to evaluate the BFT model, and the PTFT model is also doing the same, where it's trying to return multiple steps. However, you can see that there's issues also with the output. It's really returning larger numbers, and this is also illogical, and the percent accuracy is kind of bad because we used a function or a tool to extract the math result from the text output. And doing that, it kind of chopped off a lot of the response from the model. So finally, we kind of moved on to using a model that actually returned text with the logical reasoning instead of trying to prompt the model to only return the math response. Since it is a language model, it did return better results when we had it return text as well as numbers.
So as Alexis mentioned, for our final implementation, we used the small LM2 model um, and trained that in order to get our results. So the output was text responses that were responding with a chain of thought. So it would solve the math problem correctly, but with a chain of thought logic behind it. And this went to show that our previous attempts with just numeric outputs, so anything returning just numbers or a latex output, would not work. And in order to do what we wanted to do for this project, we would have needed another tool outside of the LLM to work with the LLM to get it to do what we wanted. Now we'll just briefly go into our Hugging Face demo. So using our final model that we trained, we hooked it up to Hugging Face to provide the simple UI where you can insert the problem type. So the derivative, if you wanted to find a derivative addition or root. So let's try a derivative. For example, we can do x squared plus 3x. And these are basically the same model. As you can see, it's returning more of a chain of thought, logical response since it is an LLM. Um, we can do the same with an addition problem. and this provides the answer. So, in conclusion, we were able to explore the significant challenges that the LLM models faced in solving mathematical problems, um, from their struggles with symbolic manipulation to difficulties in some logical reasoning and returning just like a latex value. But by implementing the targeted training strategies, we were able to return more of a like a logical reasoning output. And this opened a lot of conversations and opportunities for us to look into how we can train these models to return just numeric outputs.
So further research, large language models still are not that great at solving math problems. And the reason we chose to use derivatives in addition is that they're simple, and it's something that is manageable to train a model on with a limited amount of compute. So different approaches include hybrid, which is a very popular approach for models, is to basically have some sort of agentic approach where models are solved or the math problems are solved using something along the lines of Python or a built-in calculator, and then the reasoning itself is done by the model. So further research would basically further go into looking into these reasoning type of problems. However, the data need required for this and the amount of compute required for this is out of the scope of this project. But that is something that could be looked into in the future. And in general, using these hybrid approaches and then instead using the model to simply focus on reasoning and problem solving is the way to go.